Is it okay? Now we are going to simplify. After that, the simple procedure. First, we will take the third term. So, third term we are going to simplify EA minus AE acting on psi. So, everything acts on psi, acting on psi. And we know that E equals IH cross D partial D by dt, we know already. So, IH cross D which acts on psi, so dA psi by dt, okay, minus A IH cross D psi by dt. And this can be simplified as keeping A as constant, you will have to differentiate the other one. Keeping psi as constant, you will have to differentiate the another one. So you will have these two terms. So this term can be converted into two terms. You have kept A as constant, you have differentiated, plus psi as constant, you have differentiated the other one. This term let it be like this. The first and third term get cancelled. So you have only this term alone. So this can be simplified as IH cross psi dA by dt. Any doubt? So now we will simplify phi p minus p phi. So phi p minus p phi acts on psi will give you p is nothing but your minus IH cross del. So minus IH cross phi del phi plus IH cross, okay, minus into minus plus, so plus IH cross del phi psi. Is it okay? P equals minus IH cross del, sorry, minus into minus plus, so plus psi, IH cross del phi psi. Now this term can be written as del acts on phi and psi together. So keeping phi as constant, you will differentiate psi. Keeping phi as constant, you will differentiate phi. So that will give you two terms. The first two terms get cancelled. The remaining term will be this term alone. So IH cross psi del phi. So this term can be replaced with this term. Okay, very simple. So we have written the phi terms exactly like this. After simplifying this term, see this is first two terms, we have simplified this. Can you remember? We have simplified this. The last term let it be like this. Now these two terms I am going to take the common out. So you have IH cross EA, here IH cross ECA is there, C alpha is there. I am going to multiply with C and divide by C. So that will give me C common out. So IH cross EC alpha, it will be 1 by C partial dA by dt plus del phi. Okay, equation 8.129. Have you seen this term earlier? You would have studied in electromagnetic theory. This term is your term for electric field, expression for electric field. Your electric field E equals minus del phi minus 1 by C partial dA by dt. A is the vector potential and del phi is your scalar potential. Okay, del phi is a scalar potential and this is the expression for electric field F. And you know, I have written as electric field as F because we have already written as E as energy, so we will get confused. So that's the reason that I have written as field F. So usually in all the books it will be written as E, electric field E, but we should not get confused with another E. Another E stands for total energy. Okay, so that's why I have written as F. So F equals minus del phi minus 1 by C dA by dt, where F stands for electric field. Okay, now look at this term. This is your electromagnetic field. So we have inserted now the Hamiltonian, which we have chosen as Dirac Hamiltonian. We have applied the potential, vector potential, scalar potential, and look at this expression. We are going to replace this as electric field E. See, look at this expression. This contains A, vector potential contained with magnetic field B, scalar potential, the difference of, that is d phi by dr is nothing but your electric field. So these two factors clearly say that we have applied only electromagnetic field. Okay, so now this one can be replaced with E minus E phi whole square minus m square c power 4. Okay, this is your minus F. So I have written minus IH cross EC alpha F, and the last term is here. So almost we have simplified. We are going to have this expression, and we are going to simplify this expression and substitute and get the answer. The last one is we are going to simplify this. using the identity. So we are going to simplify this. So we know this identity alpha dot p times alpha dot q, which is equal to p dot q plus I sigma prime dot p cross q. So this is identity, you have to learn by heart. Okay, this is identity. Now we are going to use this identity for simplifying this last term. Last term contains alpha dot Cp minus Ea whole square, alpha dot P multiplied by alpha dot Q. So I can write this as alpha dot Cp minus Ea multiplied by alpha dot Cp minus Ea. Okay, here P is Cp minus Ea, Q also Cp minus Ea. Very simple, you can compare these two. We are going to use this identity. Your P also Cp minus Ea and Q also Cp minus Ea. So you are going to use this identity in this expression and we are going to simplify. So alpha dot Cp minus Ea whole square acting on psi will give you Cp minus Ea whole square. See here, P dot Q. P and Q both are the same. You are going to, so we can square it. Cp minus Ea whole square plus I sigma prime dot P cross Q. P cross Q is this one. Okay, your P is this one, Q is the same, Cp minus Ea. So Cp minus Ea, just take this term and simplify and insert it, we will get the whole expression. So Cp minus Ea cross product with Cp minus Ea will give you, first we are going to cross product with Cp with Cp. Okay, so C squared P cross P. P cross P, A cross A, B cross A, I cross I, answer is 0. The first point is over. Second one, A cross A, that also will become 0. So we will have to have only two terms. So this with this term and this with this term. So this is the first term will be your minus C E P cross A, correct? Your P cross A, and second term will be A cross P. Is it okay? Now we know that P equals minus IH cross del. So we can write this as plus IH cross CE del cross ASI. Again the minus will get cancelled. You have IH cross CE A cross del psi. Now del cross ASI. Earlier, if cross is not there, del ASI, we can easily, that keeping A as constant, you can differentiate the other one. Then we will do like this, correct? But here del cross is there. So we have to use vector identity, no other way. Okay, if cross is not there, simply del ASI is there, it's very easy to simplify. Okay, so now del cross ASI can be written as vector identity exactly like this. And I am going to interchange these two. So del psi cross A can be written as minus A cross del psi. Okay, A cross B equal to minus B cross A. So similarly I am going to change this one. So this equation, so this using this identity, this term become, this can be replaced with these two terms. So you have IH cross CE del cross ASI minus the common out. Okay, IH cross CE A cross del psi, this term, and the last two terms will get cancelled. Here the first term. So we have found out the value of this term as IH cross CE del cross A. What is del cross A? Del cross is nothing but your magnetic field B. So IH cross CE B psi, magnetic field, the term magnetic field has come. Okay, very simplified one, elegantly Dirac has found out. Now substituting, now we are going to substitute now. So the whole expression, we have found out only these two terms, correct? So we are going to substitute in this term. We will get as Cp minus Ea whole square plus I sigma prime dot this term. So you have IH cross CE B. Okay, B stands for magnetic field. And I and I squared minus 1. So we can write this as minus H cross CE sigma dot B. Any doubt up to this? So totally, this is the last one, correct? Last term only we have simplified. So we can write this expression as, total expression as E minus E5 whole square minus M square C power 4 electric field term. This is your magnetic field term and this will be your interaction term. We are going to look at the first two terms. So we have 5 terms now. 1, 2, 3, 4, 5. Suppose if there is no electric field or no magnetic field, there is no electromagnetic field, then there is no electric field as I said. So this term will go off. No magnetic field. So this term will go off. No magnetic field. This term will go off. What is this expression? This expression is E minus E phi whole squared. This is a relativistic equation for free particle. This expression. Okay. Now we have applied the electromagnetic field into two terms. A potential term like P we have changed into P minus EA by C and phi with E minus phi. So that's why we have obtained this complete equation with the electromagnetic field, which is nothing but 8.142. So the first two terms in equation 8.142 refer Schrodinger equation of free particle. Okay, now this term and this term and this term refers the Schrodinger equation for a particle in the relativistic quantum mechanics in electromagnetic field. Now we are going to find out the significance of all the terms, the remaining terms. Okay, first we will take these two terms. These two terms, we are going to find out the significance now. What are the importance of the terms? So this term is nothing but a squared minus b squared. I can write this as a plus b times a minus b. I can write this equation. So this can be written as e minus e phi minus mc squared multiplied by e minus e phi plus mc squared. Now I am going to replace e as e prime plus mc squared. So this expression can be done with the help of relativistic. So concept of specialty of relativity. So E can be replaced with E prime plus mc squared. So this expression becomes E prime plus mc squared minus E phi minus mc squared. These two terms will get cancelled, and the next term E can be replaced with E prime plus mc squared. So E prime plus mc squared minus E phi plus mc squared. These two will get added, and we will have 2 mc squared. So you have E prime minus E phi, E prime minus E phi plus 2 mc squared. Now this E prime minus E phi will be very small value than that of mc squared, because C value is 3 in 10 power 8 meter per second. Squaring that will give you very high value. So mc squared value will be very high compared to that of E prime and E phi. So we can neglect these two terms. So this term, the totally E minus E phi whole squared minus these two terms, okay, can be written as E prime minus E phi. We can neglect this term, we can write 2 mc squared. So this equation becomes this term only we have replaced with this one. Okay, these two terms we have taken, we are going to replace this term, okay, for this term. So we have E prime minus E phi 2 mc squared, as I said, the electric field term and magnetic field terms as it is, which acts on psi, which is equal to 0. Now divide this equation by 2 mc squared. So we are going to divide this equation by 2 mc squared. So E prime minus E phi 2 mc squared will go off, minus I get cross EC alpha dot F divided by 2 mc squared. Here I can pull one, I can multiply and divide by C and pull C out. Come on, I am going to multiply with C and divide by C. Okay, and C I am going to take C out. So this is square term. So when you are going to take, that will be C squared, that will become C squared. So C squared divided by 2 mc squared, this will become P minus EA by C, and this term divided by 2 mc squared. Okay, now E prime is replaced by E. So this becomes E psi. I am going to bring this term to right hand side. So that will be E phi. This term I brought it front. C squared get cancelled. You have 1 by 2m P minus EA by C whole squared plus E phi. Minus E phi goes to that side. So plus E phi. The remaining term will be, you have this term, magnetic field term, E h bar divided by 2 mc sigma dot b. Okay, this C and this C will get cancelled. So you have E h cross divided by 2 mc sigma dot b plus this term. So you have I h cross So alpha dot F divided by 2mc. That C and this C will get cancelled, acting on psi, which is equal to 0. Okay. Now again, when there is no electromagnetic field, you consider. So B becomes 0, F also will become 0. This equation is ordinary Schrodinger equation. See, with a see, and this also will go off, correct, when there is no electromagnetic field. So this is P squared by 2m plus E phi. E phi stands for potential, your potential energy. See, ordinary Schrodinger equation. We started with Dirac's Hamiltonian. So we have obtained with Schrodinger equation in the absence of electromagnetic field. So theory is fully good, elegantly done by Dirac. So first two terms represent the Schrodinger equation in the electromagnetic potential. Okay, and this term is magnetic dipole moment of the electron. This term, the last term, refers electric moment of electron. So this stands for magnetic field and this stands for electric field. Okay, so very important term. This is very important term. As I said in the introduction, we are going to have the third term, is very important term, and this can be replaced by mu dot p, where mu equals minus E h cross sigma divided by 2mc. Remaining term, you just go with this term as mu. So this term can be written as mu dot p, where mu equals this one. So this is magnetic moment interacts with the external magnetic field B, magnetic moment of the electron, which interacts with the external magnetic field. This term is very important term. Okay, and this magnetic moment can be written as mu equals EF by mc. EF by mc, E remaining term h bar sigma prime divided by 2. You just keep it as S. The remaining term will be E by mc. So E by mc with S. Okay, S equals h bar by 2 sigma prime. So this was postulated earlier by Uhlenbeck and Goldsmith. Can you remember? I started with Stern-Gerlach experiment in the year 1921. So at the time only we know that this is plus half and minus half, quantized. Whereas Uhlenbeck and Goldsmith, they predicted that it must be h bar by 2 and minus h bar by 2. Now Dirac also had done the same thing. He also got the same answer, h bar by 2. So it is inside the magnetic field, magnetic moment of the electron. Okay, so S equals h bar by 2 sigma prime, which is the value postulated by Uhlenbeck and Goldsmith. This is nothing but spin angular momentum. So thus the Dirac equation predicts that for a spin half particle, the magnetic moment is given by by the relation mu equals minus E h cross sigma prime by 2mc. It is a very good agreement with the experimental results for the electron, but not for the proton nor for the neutron. Later they have modified and they have obtained the same results. Okay, so this is the idea behind the magnetic moment of the free electron for the Dirac particles. Okay, so thank you students. We will see you in the next class. Bye students.